So finding all the factors of 30. First of all, you need to know what a factor is, and it's easy to get confused with multiples. They're often taught in the same lesson, and they are kind of related, so often students aren't sure which one's which. Factors are numbers that go into the number, so in this case factors of 30 are numbers that we can divide into 30 and still get a whole number. When I do this to students, when they know that, they're quite happy to then start finding factors. They might say 3, they might say 10, 5, and they can generally get nearly all of them. So maybe they can get all of them, but without a systematic method here to find them all, they struggle. So what I always suggest to students is just start with the number 1 and then think how many times 1 goes in, and that will find you the other factor, the pair. 1 goes into 30 times. If those were the only factors, it would be a prime number, but those aren't the only factors, so 30 isn't prime. So once we've tried 1, we should try 2. We should know 2 is a factor because 30 is even, and half of 30 is 15, so 15 is also a factor. After 2, we should try 3, and we should know 3 goes in because 30 means 3 tens, so 10 is also a factor. After that is 4. 4 doesn't go into 30, it's not in, 4 isn't a factor of 30, 30 isn't in the 4 times table. So there is no pair for this, so I'm going to get rid of the 4, that's not a factor. After 4 I'd try 5, and 5 goes in 6 times. After 5 I would try 6, and 6 goes in 5 times. And actually, as you can see here, I've got the same 2 numbers, so actually I should have stopped when I got to 5. Those are all the factors. 30 has 8 factors, or 4 pairs. Okay, multiples are effectively that numbers times table. So in this case, multiples of 20 are the 20 times table. So 20, 40, 60. So those could be 3 answers for 3 multiples of 20. They don't have to be the answers. Those were just the first 3 multiples of 20. We could have any number that's a multiple of 20. So anything that's in the 20 times table, or anything that can be divided by 20 to give us a whole number. Okay, when we're adding decimals, we just need to be careful here. Quite a common mistake I see is that people think of it as 2 add 13, and they say the answer is 0.15. That would actually be wrong, so don't do that. What we need to do, when we always do when we add, say we were adding 680 and 32, we were always taught to line them up down the right hand side. And what we're doing when we line those up is we're lining up the decimal points, which are invisible if they're whole numbers, but we need to be aware of this when we're adding decimals together. So to add these together, I am going to set them out like that so that decimal points are underneath each other. That way it's important now that we're adding the 2 and the 1 together. So there is a hidden 0 here, so I could put that in now if I want to. I could have actually put it in at the start. I mean, that is a good way of dealing with it. Some people just think of it as 0.20 plus 0.13, and then when they see 20 and 13 and get 33, it actually gives them the right answer. So 2 ways of dealing with it. One is that you use the column method and make sure the decimal points are in a line. That way when you add them together, you're adding the right numbers from the right columns together. Or you can just make sure they have the same amount of decimal places by adding on zeros. That way we can kind of cheat and think of it as 20 add 13. Okay, multiplying. There's lots of methods for doing this. First thing you need to decide is what is your method. I work with lots of students who don't actually know which way they're going to multiply. Common methods are column method, how we were traditionally taught, set out like this. There are other methods like lattice or the grid method. What I would say is make sure you can multiply, figure out what your method is, and if you're struggling with it, I mean, any student who I find that struggles, I always get them to do the grid method, which I'll show you. So in the grid method, we're going to break 23 down into 20 and 3, and 45 down to be 40 and 5. and we're going to do 4 multiplications. So we're going to do 20 times 40, which we do by doing 2 times 4, which is 8, and we add on 2 zeros because there was a 0 here and a 0 here. Next up, we're going to do 40 times 3. So 4 times 3 is 12, and again there's 1 0 to add on from the 40. 5 times 20, 5 times 2 is 10, add on that 0 from the 20, and then the final multiplication, 5 times 3, 15. And then we would add these together. So 800 plus 120 plus 100 plus 15. And we're going to add them in a column method. This column adds up to 5. This column adds up to 3. And the final column adds up to 10. So put 0, carry the 1 up. So 1035 is our answer. Okay, so dividing now, 280 divided by 5. So like multiplying, you need to have a method that you know is yours for dividing. The most common method is short division, which is also known as the bus stop method. And the way this works is you put 280 in the bus stop, and you put the 5, which we're going to divide by, at the front. To be good at dividing, it does help to be good at your times tables. Because we're dividing by 5, we need to be good at our 5 times table. One method is to just write out your times table underneath. It can speed things up. And now we're going to do it. So we start off by thinking, right, how many 5s in 2? And 2 is smaller than 5, so straight away we've got to be thinking doesn't go in. So we put a 0 and we carry that 2 onto the 8, making 28. And now how many 5s in 28? So if we look down our list, 5 goes into 25 5 times, and into 30 6 times, and 30 is bigger than 28, so we're going to go with the 25. So 5 goes into 28 5 times, because it goes into 25 5 times, and because 28 is 3 bigger than 25, we've got 3 left over, which gets carried to the next column, turning that 0 into 30. And now how many 5s in 30? Well, we can see that's 6 5s from our list. So it goes in exactly to 30, it goes in 6 times. So 280 divided by 5 is 56, and that's using the bus stop method. So you can, or short division. There are other methods like long division. I've even seen chunking, which is a terrible way of dividing. I would always recommend you using short division or the bus stop method. Okay, so next question, sharing in a ratio. Ratio is something that a lot of students struggle with because they're not entirely sure what it is. A 2 to 3 ratio is just a way of describing how the money is going to be shared out. It's not going to be shared equally, it's going to be shared fairly based on this ratio. And 2 to 3 basically means someone gets 2 parts and someone gets 3 parts, which means there must be 5 parts. So someone's getting 2/5 of the money and someone's getting 3/5 of the money. And that's where the ratio comes from. It comes from just changing 2 fractions into a ratio. It is still related to fractions. So basically someone's going to get 2/5 of the money and the other person's going to get 3/5 of the money. Why might that be the case? Well, maybe 2 people were washing cars and someone washed 2 cars and someone washed 3 cars. So we're going to share the money based on the work done rather than just sharing it equally, half each. So the first thing we would do here is, because there's 5 parts, we want to figure out, well, what's 1 part? What's 1 part of 80? So we're going to divide 80 by 5. And we can use the bus stop method like we just practiced in the last question. So we think, right, how many 5s in 8? Well, 5 goes into 8 once, and 8 is 3 bigger than 5, so we carry on our 3. And we say, right, how many 5s in 30? Well, 5 goes into 30 6 times, so one part of this ratio is 16. So the person getting 2 parts gets 2 lots of 16, which is 32, and the person getting 3 parts gets 3 lots of 16, which is 48. Now there are other ways of thinking about this. Some people like to think of it and draw like a bar model for it. So if someone gets 2 parts and someone else gets 3 parts, we need to split this £80 up into that ratio. Well, what we need to do is figure out what each part is worth. So we divide our 80 by 5, which we just did a minute ago. So each part's worth 16. So the person getting 2 parts gets 2 lots of 16, and the person getting 3 parts gets 3 lots of 16. So that's another way of thinking about these ratio questions. We can sort of draw them, we can bar model them, and that generally helps people who are struggling, but at the same time they have to know how to draw the bar themselves, and that can cause issues as well. Okay, so next we're going to find a fraction of an amount. So we're going to find 1/7 of 203. Now a lot of students I work with are really unsure what this means. Basically, a seventh of something just means we're splitting it into 7 equal parts, which is the same as dividing by 7. So when a lot of students say to me, I don't know how to do this, I'm like, you do, you just don't realise. So we're going back to our bus stop for division, and we're just going to divide 203 by 7. So 7's a bit of a trickier times table to what we just did before, so again it's really helpful to be good at dividing, to know our times tables. And we're starting with how many 7's in 2? Well, 7 is bigger than 2, so it definitely doesn't go in. We put a 0 and we carry that 2 on, making 20. And now we think, how many 7's in that 20? Let's just carry on our times table and see if it helps. 14, 21. Okay, 21's too big, so 7 goes into 20 twice, it goes into 14 twice, and there's 6 left over from 14 to 20, so it's the 6 we're going to carry next, and we're going to do how many 7's in 63. If I carry my times table on, I'll eventually get to 63. It's the 9th number in the 7 times table. 7 goes into 63 9 times. So 1/7 of 203 is 29. So it's as simple as that. If you want to find a fifth of something, you divide it by 5. If you wanted to find a 20th of something, you would divide it by 20. So that's how you find a fraction of an amount. Okay, so multiplying fractions together. This often causes a lot of confusion because people get confused with how you add fractions together with how you times fractions together. Now, multiplying fractions together is actually incredibly easy and is one of the main points of fractions. That's why they're so useful. Times them together is really easy. Adding them together can be hard, and that's what causes problems, because if we were adding 2/5 and 2/7 together, we've got to do something to these to start with so that we can add them together. We can't add them as they are. A common mistake was people would go 2 add 2 and 5 add 7 is 12. That doesn't work. There's actually a lot more we've got to do that. And that's where people hate fractions from stuff like that. But actually multiplying fractions together is really easy. We literally just times the 2 top numbers together. So 2 times 2 and the bottom numbers together. The 5 times the 7, and it's 4 over 35. So multiplying fractions together really easy, and part of the issue with that is it's so easy that when it's taught in class we do it and we think that's easy, that's brilliant, and then we move on and we don't spend much time with it, and so we forget how to do it. So that is how you multiply 2 fractions together. Okay, next question is we're going to find a percentage of an amount. So percentage is a good way of describing an amount of something, how much of something we're going to have. Generally, students are pretty good at this. People I work with generally have a good idea. And the key to finding a percentage of an amount without a calculator is to find 10% of something. So you need to know how to do that to start with. And this is all based on the fact that all of it, or 100% of it, is 80. So how do you find 10%? What do you do to go from 100% to 10%? Well, you divide by 10, because there are 10 lots of 10% in 100%, so that means we divide the 80 by 10 as well. So to find 10% of something, if you're starting from 100%, you always just divide by 10. This is easy because 80's got a 0 on the end, we just get rid of it. What really happened is they all moved down a column and we got 8.0, but we don't bother putting the 0. But worth remembering that if we're finding 10% of 63, then all the numbers move down a column and 10% of 63 is 6.3. So we're after 20% of 80. Once you've got 10%, it's really simple then to get to 20%. We can use 10% to find lots of different percentages, and here we should be able to spot that you double 10% to get 20%, so we're going to double the 8. And being good at times tables, 2 8s are 16. So 20% of 80 is 16. I'll put it up there as well. So really key when you start learning about percentages is that you know how to find 10%. You know that you should be dividing by 10 and you're confident on how you divide by 10. Once you know how to find 10%, you can halve it to find 5%. You could times it by 7 to find 70%. But a lot of this is all based off, can you find 10%? When you can do that, you can start to find much harder percentages. Okay, we're on to the bottom row here, the last 3 questions on this sheet, and we're going to find the area of a rectangle. Now, in my experience, students don't know how to find the area of a rectangle very well because they don't really understand why they're doing it. They were taught it badly at primary school and they can't remember whether they're adding the sides or timesing them because they don't really know what it is, and that's fair enough. It's a strange concept. What is area? And generally students have an idea if you talk about how big is this room, is it bigger than the kitchen, is it bigger than the living room, and that's what area is. It's just a measurement of space. But in a maths exam or just in class, people just we're trying to find the area of these tiny little rectangles, and it's kind of a weird concept. What does it mean? To find the area of this rectangle, let's just do it to start with. We actually times the length and the width together to get 28, and that would be 28 centimeters squared. What is a centimetre square? Well, this again is sort of where the confusion comes from. Why did we times 7 and 4 together? If I come down here, I'm actually going to try and draw this rectangle. So it was 4 squares wide and 7 squares long. So this is our rectangle. It's a 7 by 4 rectangle. And we split space up into squares. We're going to figure out how many squares are in this rectangle. That's the thing we use to measure space. So if I start counting them, and this is how we should be taught it in primary school, that we count the squares. How many squares are there? That determines the size of it. And as a teacher, you're hoping that we're not counting squares forever, that at some point someone's going to realise, hang on, we don't need to just count every square. If we times the 7 and the 4 together, we will get our 28 without having to count each square. So that's why we times the length and the width together. It tells us how many squares are in that shape, in that rectangle. We need to learn the rules for the area of a triangle and all the other shapes, but the first rule we should learn is how to find the area of a rectangle, and we should feel confident that what we're doing there is figuring out how many squares are in it. In this case, they're centimetre squares because the sides were measured in centimetres. If they'd been measured in metres, then the area would be in metre squares. So squares where each side is 1 metre long. So to recap, to find the area of a rectangle, you times the length by the width, and the reason we're doing that is we're figuring out how many squares are in that shape. And we'll forever be figuring out how many squares are in every shape, even in a circle where they don't fit in because the circle's curved. We're still, when we're finding the area of that circle, going to be trying to figure out how many squares are in that circle. Okay then, angles in a triangle. So, again, another topic that students seem to struggle with. Generally because I think they're possibly a bit unsure of what an angle is. An angle is a measurement of turn. We could probably all appreciate if someone told you to turn and face the other way, what that means. And an angle is just a way of measuring an exact turn. Are you turning all the way around, or a quarter of the way around, or just a small amount of the way around? The angles in a triangle always add up to the same number. Whatever the triangle is, these three angles, and they'll always be three because it's a triangle, they will always add up to the same number, and that number is 180 degrees. So to do this kind of question, you need to know that they will always add up to 180 degrees. You also need to be aware that if it's not a triangle, if it's a square or if it's a pentagon, that they won't add up to 180 degrees anymore. You have to either learn what they'll add up to or come up with a way of remembering, and there are ways of remembering. But for this question here, we just need to know that these three angles in the triangle add up to make 180 degrees. You can always find a missing angle, which in this question is marked with an X, if you know the other two. Well, we know this one's 37. And another thing we need to know is what this means. This square here is representing a right angle, which is 90 degrees. So what we always do is we add up the two we know. So 90, and let me undo that and put it in the right colour, 90 and 37. So we're going to add those together, and they add up to give us 7 for that column, and 9 add 3, 12, 127 degrees. So the two we know add up to make 127, and because we know all three should add up to 180, to find our missing angle, we're going to do 180 take away 127. To do this, we're going to need to borrow here. Common mistake is people just put a 7 on the bottom here, but actually we need to borrow from the 8. So we take 1 off the 8, making 7, bring that 10 down, bring that 1 down to make 10, and 10 take away 7 is 3. Then we go to the next column, and it's now 7 take away 2 because we borrowed from the 8, and 7 take away 2 is 5, and then the final column, 1 take away 1 is 0. So the missing angle, x in this case, is 53 degrees. I'm going to put there. Okay, and that's how you find the missing angle in a triangle. You can always find the missing angle. If there's one missing and you know the other two, you can always find that third and final angle by knowing that all three angles should add up to make 180. So you add up the two you know and take that away from 180 to find your final angle. Okay, so final question on the sheet. Powers, how do we do these? Again, this causes a lot of confusion for students. What does this little 3 here mean? Quite often I will see someone just do 2 times 3 and say it's 6. Now that little 3 there, that power of 3, doesn't mean you times by 3. What that's referring to is how many 2's are being times together. It means there's actually 3 2's being times together. So it means 2 times 2 times 2. A bit confusing, fair enough. The reason for it is if we were timesing 58 2's together, instead of having to write 2 times 2 times 2 times 2 58 times, with this method we could just put a 58 there, which is telling us to times 2 by itself 58 times. So that's the point of powers. It saves you from writing out something really long, but it does cause confusion. So 2 to the power of 3, also known as 2 cubed. 2 times 2 is 4, times that by 2 is 8. So 2 cubed is 8, that means that 8 is a cube number. And on the next question, again, this causes a lot of confusion. What does this sign mean? Is it the bus stop method? No, it's not the bus stop method. That is the sign for the square root. So that's saying, what number do you times by itself to get 25? What's the square root of 25? So we've got to think of a number that when you multiply it by itself, you get 25. And key to this is knowing your times tables. So if you're familiar with your times tables, you might think, oh yeah, I know, it's 5 times 5 that makes 25. So the square root of 25 is 5. And we shouldn't write that, we should just put that there to show that the square root of 25 is 5. If you're not good at your times tables, you might have to do something like consider all your square numbers. So 1 squared is 1 times 1, 2 squared is 4, and work your way up through your square numbers, figuring each one out until you get to the number in this question, which was 25. So then you'd know the square root of 25 is 5. So again, another reason to be good at your times tables. If we go back to the first question where we cubed 2, if we were asked to find the cube root of 8, what number do you cube to get 8? Well, that would be 2. So it's not always just a square root. This symbol can occur with a little number here, in this case of 3. That meant the cube root. We don't put it, but there's a little 2 there. So it's not put, because if it's not there, it's just implied that it's the square root. So powers are numbers being times by themselves, and then this weird symbol like a bus stop method, this root symbol, you just have to figure out what number was times by itself to give you that. So the square root of 25 is 5.